Welcome, everybody. Good morning, good afternoon, good evening. First, let me say how much we appreciate you joining us today. We know certainly manufacturers are pressed to their limits today, so taking an hour out of your busy schedules to listen is very much appreciated by us. Today's agenda, we want to do a quick introduction of Dassault Systems and who we are for those that may not be familiar with our company. Then we'll look at some market and technology trends. Then we'll talk about the planning and scheduling challenges that a lot of you are feeling today in the complex discrete manufacturing industries. My colleague Moss Rosen will go through some detailed capabilities of our advanced planning and scheduling solution. And then we'll take a couple of transformation examples, customer examples that we'll share, and then talk about return on investment. At the end, we will have a Q&A period, as Heidi mentioned. Our company, Dassault Systems, is one of the largest, I believe the 9th largest software solutions company in the world. We are over 25 years old at this point, and we're a very focused company. We like to think of ourselves as a scientific company, but we are very keenly driven by the design, engineering, and manufacturing processes. We have over 16,000 people worldwide, with a global R&D center outside Paris, with 64 different labs around the world, where we are developing what we consider to be very much game-changing solutions built on our 3D Experience platform. Our 3D Experience platform is what drives our brand applications, and a lot of these you will be very familiar with, CATIA, Simulia, and all of these brand applications we bring together within our 3D Experience platform to support 12 industries as represented on the right-hand side of the screen. For today's webinar, we represent the DELMIA brand, which is the supply chain and manufacturing brand for Dassault Systems. So that's a short introduction of who we are. Let me talk about the industry and really what's going on from a transformational standpoint. And this is not just in industrial equipment or transportation mobility, but we're seeing transformation to an experience economy across all industries. We're seeing a change from a product-centric world where you literally bought commodity products. So what you purchased and acquired for your needs was very similar to what your neighbor, what your friend, or what your competitor was purchasing. That has rapidly changed over the last few years and is continuing to change as we move into really an economy where experiences are valued. And we're talking not only at a commercial level, but at a consumer level. Experiences in the whole approach to how you buy products is rapidly changing. And one of the keys here is that great experiences actually build your business. So it is not something that you want to ignore. This is a change that is significant across all areas of the economy, and it's really important because those experiences and your success in delivering experiences really are going to drive your future business. This change to an experience economy is also changing manufacturing, transforming manufacturing, if you will. Everyone is looking at leveraging technology to actually help deliver these new experiences. A couple of our customers here have envisioned manufacturing in very different ways than we've looked at manufacturing before, where they're really integrating the human aspect with advanced technologies to really reinvent manufacturing processes in how they build products. And the driver behind this is the fact that customers are demanding very unique experiences that represent their very specific needs, again, at a commercial level, but also at a consumer level. Well, we believe that the DELMIA brand of Dassault Systems is very uniquely positioned to support this transformation in manufacturing, which, as I said, is being driven by demands from the general economy in the transformation to an experienced economy. If you look at the DELMIA solution portfolio, it is striking how focused we are on the supply chain and manufacturing operations of global companies. We have a complete comprehensive capability in the virtual world. Our digital manufacturing suite gives you all the capabilities to essentially model, simulate your manufacturing environment without ever touching a physical asset. So we then look at our manufacturing operations management capabilities, which are leading in the industry, where you are driven from your business processes on the shop floor and are executing to a level that is really required to support the manufacturing transformation that is going on today. And then our supply chain planning and operations capabilities sit at the top, and we're actually going to focus on our plant level capabilities during today's discussion, specifically around master planning at the plant level, and then of course detailed scheduling, rescheduling, and optimization capabilities. And this is where you really want to look at transforming the way you have done planning and scheduling in the past, looking towards a unified platform approach. As the 3D Experience platform brings to this equation, you really want to be looking at that level of capability as you think about transforming your own operations. So if we go back and look at I'll say the digital transformation that is going on in the advanced planning and scheduling arena, we go back to the mid 20th century, where you were looking at static manual boards of varying sizes, but essentially you were doing planning on a very visual basis on a manual board. Then you move into the 1970s and the 80s, and technology, I'll say mainframes start to get smaller. The advent of the personal computer starts to penetrate business, and you're seeing the development of MRP2 and some very static tools to support push manufacturing. Then as we get to the end of the 20th century, we really see a focus on lean manufacturing, really high level focus on capacity utilization and pushing out very efficiently commodity-based products. And we see the development of advanced planning systems, but of a non-collaborative nature. And then we certainly see the proliferation of Excel. And I think universally, manufacturers still look at Excel as one of the most proliferated business tools ever utilized across global operations. But now we're moving into really the industrial renaissance. Some people have termed it the fourth industrial revolution, but we're moving into that time period now where the experience economy is driving very much a production of one requirement, which is really going to require advanced planning systems that are both agile and collaborative in nature. because manufacturing is not being run as a single plant. It's really being run as a network of plants. So you're looking at capabilities that have to span within the four walls, but also have to look outside the four walls on a total capacity total capacity basis in the planning and scheduling needs that are required. Essentially, though, at a plant level, planning and scheduling today is a must. You really, to effectively manage a production of one environment where unique experiences are being requested by your customer base, you really have to have this kind of capability. No longer will I'll say the spreadsheets and the pivot tables really be effective going forward. The world's changing. Plants are delivering solutions to all 7 continents. Customers are really demanding today not only a level of personalization they've never required before, but they're demanding answers in a very, very small time period. And agility is the key from a manufacturing standpoint. You have to deliver on time. You have to deliver that unique experience to the customer. But you have to do it in a cost-effective manner. At the end of the day, demand-driven smart factories, to support this concept, you really have to have an advanced planning and scheduling solution. The whole concept of having this advanced planning and scheduling solution is really its direct impact on your operational objectives. If you look at responsiveness to customer orders, in the demands that are being delivered. If you look at production capacity, and most importantly in today's very competitive environment, if you look at how fast you can get new products to the marketplace, an advanced planning and scheduling solution for your plant is absolutely critical. And you can see this borne out in a survey that was done by a research firm, L&S, just within the last couple of years. So many of you are going, well, what about, what kind of challenges are you talking about? Well, I think most people on this call will relate to many, at least one, probably many of these challenges. But, the demands that are being placed on manufacturers today, how do we increase our overall accuracy of our forecast, but then reduce our risk exposure when we're bidding on new projects? Or how do we efficiently plan and schedule our order of one complex products so that we can ensure on-time delivery and customer satisfaction? How do we manage bottlenecks? How do we eliminate bottlenecks and minimize all of those reactive, unplanned responses to what typically goes on in the shop floor? How do we maintain the correct level of inventories? I mean, essentially, one of the key elements of really excelling in today's environment is managing your stock levels effectively. In doing so, while providing that level of personalization in delivering products and experiences to your customer. Compressing manufacturing cycle times. Certainly, OEE and maximizing the utilization of your capital assets on the shop floor. And then reporting both internally, but to the customer on the progress of their products and how they're doing, any problems you see. These are all challenges that are being seen regularly on the shop floor, but more importantly are growing as the demands on manufacturing keep climbing. So a good idea, planning and scheduling is a great idea, but when you're still doing it with tools from the past that are manual, they're non-collaborative, they're really standalone and not integrated. They have a dependence on maybe a single resource or a couple of resources who are quote unquote the experts on how to look at the shop floor and make sure that things get done on time. Maybe they're just great at juggling things and moving this work order ahead of this work order. The bottom line is these are the ways of the past and really don't support what you need today. A better approach is really built around a dynamic, real-time advanced planning and scheduling solution that is focused on your plant requirements. It's dynamic in nature. It automates a lot of the more mundane tasks. It's collaborative and provides everybody a real-time understanding of what's going on. So there's a single source of truth that everybody is using. It integrates with your other business systems, and it has a simple, easy, interactive user interface that really helps drive the productive use of the solution. This is how it needs to be done today. We believe we have an outstanding approach to this. And I'm going to let my colleague Moss Rosen give you a little deeper insight into the capabilities that we can provide.
Thank you, Fred. Yes, so now we'll kind of jump into some of the capabilities that we have within our products and our solutions. From a plant-based planning and scheduling system, we present 3 different optimization engines that are help to give you the tools that you need to provide the best fitted solutions for your particular production and your plants. At the first level, we have our load leveling, which is a capacity planning tool, allowing us to look at the mid to longer term capabilities of our factories. Do we have the right tools and the right equipment? Do we need to go through capital expenditures to make sure we can maintain our capacities and meet our customer goals? And that's on the longer term, the mid to long term, from a load leveling or capacity planning and MPS level. From a fine sequencing and scheduling perspective, we also have optimization engines that allow you to find the best fit when you're working around things like production campaigns and changeover management. How do we reduce setup times to optimize and give us the best fitted solution and the best particular return? Also getting us down to the finite scheduling and finite capacity, whereas other tools like MRP and ERP, they don't have the real look at the real world of what's happening on the shop. They don't know if somebody hasn't shown up today or if the OEE of a particular machine is decreasing, therefore we might need to reschedule and adapt for that. This fine sequencing and scheduling is really more on the short-term or mid-term approach to really see what's happening within our horizon. Then we also have another optimization tool, which is our flow synchronization. This allows you to look at the various bill of materials that we have and work orders and their dependencies. If a work order or a part is dependent on another part or some raw materials, and we have an exploded bill of material, we need to be able to understand that if a semi-finished good part is not going to make it on time, that could impact our finished good. And how do we manage that? And how do we adapt and synchronize these various operations? Well, we have tools to do that in an engine that will help us to synchronize those and to make the best fitted solution again and maintain your various your goals and your customer due dates. So from a planning and scheduling perspective, what we do is we provide a constraint-based modeling system. So we can look at the various constraints, things like machines, labor, maybe we have some critical supplies or unique materials that we need at a certain point in time. So we look at those all as constraints, and then we're able to model and determine any bottlenecks that might come up in your process. Things like if we're over our capacity, what do we do to level that capacity and how can we adjust? But being able to highlight those issues is the key to our success and the ability for us to then go through and run our optimizations. Again, the material flow synchronization, we talked briefly, but this gives us the ability to make sure that we have the right parts at the right time, at the right place, so that we're not waiting around for various materials, or we're not overstocking a line and having various assets that are tied up to maintain that. We talked briefly about the cutting edge optimization engines from a load leveling and a scheduling perspective. These are tools that have been developed over the years to help optimize areas where really humans can't do it. We have a load leveling engine and their optimization engines that are criteria based, so that you would actually take and run the rules, your criteria of rules, and manage how you want your optimization to take place. What's most important for your business? Is it on-time deliveries? Then we have the optimization engine, utilize that as our primary goal. Things like what if scenarios, the ability to do unlimited simulations. So what would happen if we added another machine? How would that impact our schedule? What happens if we went down for the holidays? We closed the factory for the holidays. How would that impact our deliveries, our schedule, and other aspects of our business? All this is in an out-of-the-box collaborative tool, ways for us to utilize the tool and have others impact and have the visualization of the schedule and the plan, and being able to give out the best information available through collaborative approaches and an out-of-the-box capability. What I wanted to focus on today is looking at a digital continuity perspective. Within Dassault Systems and our 3D Experience platform, we have many tools that help with the production cycle and help us go from a infinite to a finite capacity perspective. In this particular digital continuity, all of these areas of our factory or our engineering and design are impacted by each other, and therefore need to have the ability to share information and utilize information around this whole loop. So again, what we're going to focus on today is more of the optimization perspective. So being able to look at how we have our expected capacity versus our demand and what that might mean for us. We'll also talk about balance our workload between resources, and then looking at analyzing and simulating within our various tools. So the first question we would have is what to produce and in what quantity. So what we can do is show the netted demand coming from interfaces and things like your ERP system, or maybe your stocking systems, even procurement. And what we want to do is anticipate our material constraints ahead of our production. So within the tool itself, we have the capability to see that netted demand in our top section here, our top display, and we can see the various things like planned work orders or our MPS schedule that's available to us, and the quantities over our horizon and the various months that we might have here. Down below, we can see the chart that shows that information, also incorporating your max stock levels and your target stock levels, etc. So we're really looking at your other policies and practices within the business, incorporating it within our tools, and then utilizing that to be allow us to optimize your schedule the best based on the demand and based on other inputs. How can we balance our workload and labor constraints? Well, the first thing we need to do is evaluate our bottlenecks against our labor skills. And on this particular chart, we're seeing that we have on the top section here, we have our particular workload and our various machines that are processing the operations and work orders. And down below, we can see the skill sets and their particular capacity, noting that in this case, we have a couple of red situations indicating that we are over capacity, and that therefore we need more people to help us to provide and reduce that capacity. And now we see here that we have reduced the issue by adding some more staff here. And now we're get out of that red situation, and now we're looking good for our future production. Next thing we'll highlight is our balanced workload and looking at it between our resources. So again, when to produce and on which resource, so we want to level our machine and line capacity. So we'll do that by adjusting our line schedule and capacity to improve our service rates. So the ability here to look at our current capacity for our various lines, the colors indicate the severity of our capacity issues. In most of these cases, we see kind of an orange color, which we're either at capacity or approaching our capacity. And in the darker red situations, we see where we are particularly over capacity. And we get various warnings saying that we are not meeting our service rates, And we could also see various indicators and global performance monitors that also tell us that we are now producing below our desired service rates. So what could we do to manage that now that we understand that we have some issues? So the next thing to do here is we can look at our capacity and load analysis and kind of leveling automatically using the engines to help us to do this. So again, we see some capacity limitations above. And we can see in the red and the actually burgundy color where we have some more severe issues coming up with these particular machine lines. So at this current stage, we're at an infinite capacity where we're actually going over our limits here based on our business practices. But by using our optimization engines, we're able to level that load. And if you notice now that those particular periods have now been leveled, information has been adjusted, or the particular work orders have been moved to provide the best fitted solution while respecting various things like our customer due dates and our service levels, things like that. So next we'll talk about producing on which resource our optimization engine is a little bit further here. So what we need to do is find the right balance between our business objectives and how we can produce these based on those business objectives. So here we see a particular chart here with our machine capabilities. And what we can do is we can use our optimization engine. And I mentioned earlier these criteria that we have available to us. In this case, we cover almost all of the business practices needed based on our customers and over the years that we've been developing the product. So the criteria here are going to meet just about all of the company's needs in this case. Then what we do is we take those criteria and put it into kind of a rule set here that says when we run our optimization, these are the areas that we want to have respected and therefore processed in accordance to this particular business goals. So we would do things like keeping our operations in the various groups that they were queued in, minimizing our work order lead times, and et cetera. So then when the engine runs, it's going to go ahead and run this rule, and it's going to adjust our calendar and our schedule according to these rules and get us the best fitted solution based on our optimization algorithms. Next, we could talk about running our setup and changeover times and campaign optimizations. So we have multi-dimensional setup and changeover time optimizations so that we can dynamically reduce the time between changeovers or setup times as well, therefore increasing our service rates. And I'm sorry, if you see below here, we have the various criteria that we would manage to determine how long it's going to take to do a changeover. If we're going from red to red, then we have the ability to just maintain our setup. There is no changeover time. But if we are changing various sizes of packaging, or if we're changing various other aspects or parameters within our system, then what's the time that's going to be added to make that changeover and that setup? And how can we reduce that by ganging up various orders that use the same setup, and therefore we reduce the changeover at that time? Let's talk about analyzing and simulating. So what is the best plan and schedule for us? If we have something like a production outage, how do we expedite and how do we allow the system to work within those constraints and still get things out the door and on-time deliveries? We do that here by seeing our machine Gantt chart above, and we have the various work levels down below. So we can see our various capacity in the lower half. And we can see that if one of our lines is going to go down to 0.24, meaning that that machine is going down for various reasons. There might have been a breakdown. So by simply recording that information into the system, the change in capacity or change in schedule for that particular line, or having that interface with your MES system or your MOM system, that information is now logged into the system, and now we have the ability to optimize, and we can actually push everything to the right in this case, but while still respecting our goals and our customer due dates by using our optimization engine as the right resource for that. So again, what is the best plan? Many times we want to simulate or play what-if games and to determine what the best situation is going to be to actually put into production or to go forward with. So here what we're seeing is our various tools here, but in this case we're comparing various simulations. So what we would do is we could save a kind of a checkpoint of how we look today and then make some modifications, change capacity, modify some other constraints in our system, and then look at these simulations and match them against each other, looking for the best one that fits us. So in this case, we see a lot of KPIs that are indicating whether the simulation is good or bad. And from a business perspective, then you could manage this and determine which is going to be the best solution based on your goals. So if we had to talk about service rates or on-time deliveries, whatever would be the highest here might be the best fitted simulation or solution for us. So just looking at things roughly before planning, before we've added our extra shift in this case and trying to correct any delays that we might have. On this particular screen, we're seeing that we have an advanced delay screen. So anything in green means it's all on schedule. Anything in the orange, or could be even in a red color, could be things that might be late and are going to be a little bit delayed. So what we can do here is we can manage no more delays, get rid of those delays by maybe adding another shift for our various machines. Here, if we go into a 7/24 mode, for the next 3 months, all of our deliveries will now be on time and none of them will be delayed. And this just by using our optimization engines and giving the system more real world examples of what's happening in the shop, whether we can, if we can go to 7/24 or if we have to reduce our capabilities or our efficiencies in half, how would that impact us and how can we therefore get out of a bad situation by running our optimization engines to help us to maximize our availability and maximize our deliveries. On this note, we wanted to also talk about integrations. We all know that we have many situations out there where we have feeder systems and we have other capabilities in the workplace that might need to share information. Things like human resources, the ability to determine who has shown up for work today and who hasn't. Maybe your morning planning meeting has indicated that we have a machine that's going to be under preventative maintenance today. So we want to interface with these various tools to make sure that we're getting the most up-to-date and therefore our optimization engines can schedule appropriately. So we provide an integration tool. It's called our Visual Interface Configurator. And it's a very easy tool to basically do the mapping between the various systems into our advanced planning and scheduling. We have many of these already pre-built and many of them are also certified. So things like the SAP, the HANA certified capabilities and many other certified ERP adapters, as well as pre-built ones that are available to you. And then these can be taken, these solutions or adapters can be taken by you and modified by using our Visual Interface Configurator so that you can customize them or tailor them to your needs, or as your business changes, you have the ability to then go ahead and complete these interfaces or adjust these interfaces by yourself to maximize the information provided to the planning and scheduling. With that, I'll go ahead and turn it back over to Fred.
Great. Moss, thank you. Hopefully that gave you a little insight into the extensive capabilities that we provide. But obviously many of you are sitting there at this point going, gosh, that sounds great, but what's the value? More importantly, what's the return on investment in acquiring a solution like this to replace years of manual methods? I think the good news there is the fact that we have seen really a tremendous response in customer benefits that have been reported to us that I wouldn't say make the decision to move forward in this area simple, but it certainly is compelling. If you're looking to transform the way you manage your manufacturing shop floor, I think the benefits that have been reported back to us, as we're showing here, are very compelling. A 50% reduction in cycle time, by load leveling operations and routings across the work centers to increase resource utilization. A lot of that is lead time reduction, which is typically 90% of the cycle time. or is typically 90% wait time for machines, inventory, or workers, your ability to actually load level across all of those work centers really has a dramatic impact on cycle time. Obviously, reducing machine setup time, your ability to optimize sequence and operator time by grouping operations that may share the same machine configuration, that reduces duplicate efforts. Time savings. No more morning status meetings or planning boards or shift change for load leveling the plant. You really reduce the amount of time spent, but more importantly, you're more effective in your usage of your resource time. A critical one, reducing inventory. As you move to a more, I'll say, order of one, production of one manufacturing model, really synchronization of your material inventories is a critical consideration and one of the big drivers, I think, in looking at solutions like this. And we've seen up to a 40% reduction in inventory holding costs by having the high value parts at the right place at the right time. And then raw materials, WIP, finished goods, allowing us to synchronize the bill of material and the work orders together to reduce our work in process inventory. This is a big number for most manufacturers. An increase of 100% in planning and monitoring of work orders. Customer service level increases of up to 50%, where you're actually delivering on time, even the most complicated engineered to order solutions. And then just a general productivity increase for your planners and your schedulers, because they now have the tools that give them a much broader capability than they've ever had previously. So let's look at a couple of examples. This one is an industrial pump manufacturer. This is a real customer, a world leader in the design and production of cast and forged severe service valves and steam traps. The issue here was essentially no control, or I'll say customer emergencies that weren't managed, congested workshops that drove a lot of delays within the production cycle, and little to no planning of their demand and how that would be handled on the shop floor. They've gone through, they've implemented this solution, they've rationalized it in their plant, and now they have the complete planning of the order book and how it fits in the manufacturing environment. They've improved their visibility to operations in a much more collaborative environment where the team is all working together off of the same information. And this has led to lead time reductions of up to 30% and up to a 25% reduction in work in process inventories. So a significant impact on this manufacturer of valves, and really taking what had been an organization using old tools, manual tools, and bringing them up and utilizing their plant much more effectively than they had in the past. Another example is from a cable manufacturer, Industrial Cables. And this was a multi-site deployment. And a lot of you on this call have that type of situation where you have multiple plants around the world. How do you manage all of those effectively with a solution like this? Well, this is a customer success where we've helped them achieve really new performance standards for the organization. It's a worldwide leader in manufacturing cables for energy, infrastructure, industry, building industry, automotive industry. They had a very highly competitive environment that really required significant improvement in their overall efficiency so that they could maintain a competitive position in the marketplace. So they implemented a multi-site deployment that provided significant improvement in lead time, in throughput, and material inventory reduction. It's very significant to point out that this is 25 sites across 5 continents. And even more important to point out, because I know a lot of you have questions about this, they measured their return on investment in less than 8 months across just a portion of those plants. So that's a significant, as you think about moving forward, transforming your planning and schedule, that's a significant consideration. What is my return on investment time frame? And the support I need for my business case to move forward with a solution like this. So let me summarize what we've talked about here. This is about transforming the way you manage your manufacturing facility. In doing so through a collaborative, platform-based solution for plant-level planning and scheduling. A solution that will help you meet your delivery dates, will help you meet your target dates for delivery of production of one type orders. It will help you drastically reduce your lead time by synchronizing your activities on the shop floor and leveraging your resources appropriately. It will help you reduce your inventories across all inventory categories, whether it's raw, whether it's work in process, even finished goods. It will help you increase your throughput and help you better utilize the assets on the shop floor, especially those capital intensive assets that you really don't want to see sitting idle. And overall, it will help you save time in the planning and scheduling process, eliminating spreadsheets, eliminating communication issues when spreadsheets don't line up, and will help you manage large volumes of data, especially if you have a multi-level bill of materials situation. It is a comprehensive solution that can positively impact your business in multiple ways. We would look forward to talking to you about your specific situation and see how this solution can help you achieve your goals. So with that, we're at the end of our formal presentation, and I think this would be the time that we'd open it up for some questions to Moss.
Thank you, Fred. Thank you, Moss. We do have some questions from the audience. Also joining the panel with Fred and Moss is Matthew Baird, who is a DELMIA Senior Business Consultant for Ortums. Our first question is, what is required to maintain the model that drives the tool? Is there coding experience necessary?
Yes, a good question. At this point, to maintain the master data, we have tools built in with the DELMIA Ortums that allow you to do that manually. But the preference is obviously to use our visual interface configurator, to use the other systems, your other interfaces, to get that data in and to keep it maintained and synchronized. So by using a visual interface configurator, we have the ability to run scheduled updates of information, either from your ERP system or even to your ERP system once we've done our optimization.
Okay, thank you, Moss. The next question is, are there any integration needs with shop floor equipment, or will it take the data from any other system, any other MES system?
Yes, with the visual interface configurator, again, where we can look for events and triggers. So from your MES system, if OEE is becoming very low on one particular machine, we might want to trigger an automatic downtime for that machine that goes right to our schedule. So by automatic interface, if a machine goes down or if somebody doesn't show up for work today, we would get that information maybe before our shift change. And then at that point, we have the ability to adjust our schedule and our sequencing to fit best with that information. So if the machine went down, how do we move everything? How do we have the system optimize it and move things to the right places, and maybe even adjust pushing work to another machine or pushing work to another set of skills. But that would all be done through interface at this point. And we interface with just any type of tool out there, even down to the database level, even down to the flat file level. If you're using Excel, we can interface from that as well very easily.
Okay. The next question is, how does the tool handle rescheduling of reworks?
Mm-hmm. Yeah, very good. That's one of the best capabilities that we have here, is that these kind of expedites come up. If something comes up through quality and we determine we have to put it back in cycle, or if a customer comes along and says they need something yesterday, how can we manage that? By getting the demand into the system for whatever it might be, then we use our optimization engines to slot it into the best place and most efficient place, while keeping the schedule alive in terms of not changing the go forward schedule, but necessarily changing the more immediate schedule. We can even do that within our frozen period or outside of our frozen period if needed.
The next question is, does DELMIA or TEMS integrate with the 3D Experience platform?
Yes, it does. We're obviously in the midst of integration with our own tools, and as Dassault, we have so many tools available, and with our 3D Experience platform, everything is going into that. So it's going to take a little bit more time, but we do have many interfaces already built and available to us, either coming from our manufacturing execution systems, so the interface coming there, or even coming from our digital manufacturing tools, things like our design and planning tools as well. So we are interfaced at this time, and we are to be on the 3D Experience platform with our next release, which comes out later this year.
Okay, next question. We actually have quite a few. Can you give a typical example, a few typical scenarios of integration with ERP or MES?
Mm-hmm. Sure, yeah. A lot of times we get the demand from ERP. So ERP will have our customer orders, maybe firmed orders, other information like procurement. Do we have POs? What materials are coming through on what dates? So that's a big piece of the interface that would go on from ERP. In addition, you might have tools. You would have your routers and operations potentially in your ERP. So that's a very typical approach, is to take all that information, either feed it in through interfaces, more master data information might be on a weekly basis, let's say, or we might get our demand on a daily basis or even a shift basis, those kind of things. So that would be information that we would get from ERP. From an MES perspective, we have the ability to then reschedule, optimize the schedule based on the information we got from ERP, send that information to MES to say, here's the start date for this particular operation, because we know that fits in the schedule best. So we can actually go through and update the start dates and end dates for operations within MES. MES can also feed back to us saying that an operation has been completed, or we have a machine downtime. That information can then go right back into planning, into our planning and scheduling, and then be able to use that to now optimize again for our next shift or our next day. And also and then DELMIA or TEMS can also feed back to MES and also feed back to ERP with any kind of statuses as well as changes. We also interface with digital manufacturing. So if we're looking for optimized tack times to be put into our planning and our engineering to get to our MBOM, we also have that capability, and we see that very commonly done.
Okay, thank you. How would a scheduler make changes to the model or constraints? In other words, how intuitive is the user interface?
Mm-hmm. Yeah, we find that the user interface is very friendly. It's very usable, very visual as well. And what happens is, as you move things around or as you do your optimizations, you can actually see the changes within the system. But a lot of that information is going to be fed into the system through interfaces. But with our tool, we can really stand alone even. So we have all the capabilities built into the tool to enter work orders or to import work orders from Excel spreadsheets or import any capacity changes, things like that. So very capable from a fully integrated perspective, but even from a standalone out of the box perspective.
This actually leads us to our next question. This is a multi-part question. Can DELMIA Ortem's APS stand alone, distinct from the global MOM platform integration? And would the APS need to connect to the Center of Excellence of the MES? And the last part of that question is, what's the best roadmap for integration and configuration with plant applications and MES?
Sure, yeah. Number one is we can stand alone, completely alone, without any real difficulty. It's just a matter of feeding in that master information. Obviously, you're going to be entering information then in a standalone approach into the tool itself. Whereas interfaces are going to be more efficient, but that's a very good approach to get started by running standalone. A lot of times companies, we find they want to start standalone. They want to just convert their Excel spreadsheet, basically taking information right from Excel, throwing it into DELMIA Ortems and using it as a standalone tool. But eventually getting to the point where they're going to start to model it in the bigger world. So looking at it from a center of excellence perspective is how can we impact our global schedule while using this as maybe a standalone tool or a fully integrated tool. So being able to look at our various plants and have that kind of roll up into a global view is also another capability. And then in terms of building your roadmap, that's one of the things that we would have to, it's really dependent on where you are in your roadmap and in our roadmap as well. But many times we find that the plants really need help, and they need to get off their Excel tools or antiquated tools, non-collaborative tools. Maybe they're ramping up for some new project that's coming up. So we find that they really need to get the help right away. So again, we kind of come in with an approach to get them the help they need while still integrating with the global roadmap. So we do this many times is we have customers who are building out their ERP or changing their ERP, modifying the ERP. And so by understanding what we need for DELMIA Ortems, we can now build them together and making sure that we both feed the right information at the right time. And making that more of a fully integrated roadmap to your plants as well as to your center of excellence and your global production. I hope that answered the question.
Okay, our next question is, what is the advantage of using Ortems as a detailed scheduling planning tool as compared to the advanced planning board that is part of an ERP system?
Mm-hmm. Yes, a good question. Yeah, we typically find that between ERP and the advanced scheduling, that the ERP system is not as well suited. It's a little bit further away from the shop floor. So by using planning and scheduling within the ERP system, it's not aware of some of the real world examples, like necessarily if a machine OEE is too high and we have to bring that machine down for maintenance. So with Ortems, then we have that ability to see it on the floor, be able to adjust it on the floor and make the right changes appropriately. With the ERP systems, it's a little bit slower in terms of reacting. And we also find that customers don't necessarily trust the ERP as well as they trust what's really happening on the shop floor, or maybe what's happening in the MES systems. We just find that ERP and MES and the MRP can sometimes be a little bit behind, and therefore not as accurate and therefore not as trustworthy. But what we do is we do interface back or feed back information from the planning and scheduling into ERP to make it a little bit smarter based on our optimizations. And that's another thing that ERPs don't really understand is how to optimize based on real world events. How do we get to finite scheduling?
Okay, I think we have time for one last question. We do have a few more questions here, but what we'll do is we will answer those after the webinar. So the last question we have is, can ORTEMS integrate with MFG.Pro? Does the system require build time loaded on your system? Our due dates and required dates and builds are based highly on customer types. Does ORTEMS take this into consideration?
Okay, yes, we can interface with just about any system out there. If it's a database, SQL, Oracle, just most anything. As long as we have ODBC connectors to the data, we can extract information straight through our visual interface configurator based on a schedule even. So we have that capability. Now it's the need to map the information. If you have start dates that are built off of highly complex operations and routings, then we can feed that information into ORTEMS and then use that model and that optimization to go through and make the best fitted solution at that point. And then, of course, mentioned earlier, we can also feed that information back as things are rescheduled, and then get that information back to your other systems in terms of updated start dates, or maybe we have a delay that we need to inform a customer about. Or even we find that procurement gets involved. As we start to understand when we might have some shortages, procurement can have views into the system to determine if we need to expedite a purchase, things like that. So we are fully integrated. We have lots of examples of integrations that we've done for customers. It could be something as simple as just updating a start date, or it could be something more complex in terms of updating routings and operations and tack times and those kind of things as well.
Okay, great. Thank you very much, Moss. Great questions from the audience, and thank you, Fred, for your presentation. This concludes the webinar today. As I said, we do have a few more questions that were not answered. We will address those after this webinar in the form of an email. So thank you, everybody, for joining us, and have a nice day.